Hey guys, Mr. Backenberg here. In this video, we're going to look at systems of inequalities. Now, as we're looking at a system of inequalities, we're going to be looking at more than one inequality at a time. So a solution for a system of inequalities is an ordered pair x and y that satisfies each of the inequalities in the system. And then once we've found all of the common solutions between our inequalities, then we say that we've solved that system of inequalities. So as we're taking a look at this first example, we've got the system of inequalities that includes y is greater than x squared and 2x plus 3y is less than 4. So I'm going to start with this first one, this y is greater than x squared. To graph this out, we're first going to pretend that that's an equal sign in there, so y equals x squared, and we would think about getting some ordered pairs there. So if I plug in 0 for x, I'm going to get 0 for y, so we've got the point 0, 0. If I plug in 1 for x, I'm going to get 1 for y. If I plug in 2 for my x, I'm going to get 4 for my y value. And I'm going to have a mirror image of this since we've got a parabola shape. Now, as we're looking at our inequality, it does not have the equals to line underneath it. So as we draw in this line, we need to draw in a dotted line. Now we need to do a little bit of shading, so we need to pick a test point. Normally, I would say use the point 0, 0, but because our parabola is going through the origin, we're not allowed to use 0, 0. So I'm going to use the ordered pair 0, 1. So I'm going to plug in those values, so we get 1 is greater than 0 squared. Well, 0 squared is just 0, and 1 is greater than 0. So that satisfies our inequality. So this 0, 1 point is part of the solution set. So what we're going to end up doing is shading inside of our parabola here. Now for our other inequality, we want to solve to get y alone. So I'm going to start by subtracting that 2x over to the right-hand side. So we get 3y is less than negative 2x plus 4. Then I want to divide everything by 3, so we get y is less than negative 2/3 x plus 4/3. And then to start drawing the graph, I'm going to pretend that's an equal sign in there. So y equals negative 2/3 x plus 4/3. We've got a b value of 4/3, so that's our y-intercept. So just a little bit more than 1 on the y-axis. And then our slope is negative 2/3. So I'm going to go down 2 spaces from that point and then over 3 spaces. So we're going to go down 1, 2, and then over 3 spaces. And I'm just approximating in here. And I'm going to do the same thing but going in the reverse. So I'm going to go up 2 spaces and left 3. And then as we're drawing out our line, again, our inequality does not have the equals to line underneath it. So we need to draw this out using a dotted line. Now here, our line does not go through the origin, so we can use 0, 0 as our test point. So if I plug those in, we get 0 is less than negative 2/3 times 0 plus 4/3. Well, negative 2/3 times 0 is 0, plus 4/3, we get 0 is less than 4/3, which satisfies our inequality, so we want to shade on the same side as that 0, 0. So we're going to end up shading below our blue line. And then what we're looking for in here as we're solving this system is we're looking for common points between our shaded areas. So if we look, we've got this small little region here in the middle that's shaded both red and blue. So that's actually going to be our solution set. That's where our graphs overlap. So I'm going to shade that in purple. So this purple region that's above our red dotted line, but below our blue dotted line, that's the actual solution set for this system of inequalities. Now, as we're taking a look at this example, now we've got 4 inequalities that we're going to take a look at. And as we're graphing this out, I'm actually going to start with this x is greater than or equal to 0. To graph that out, remember we pretend there's an equal sign in there, so x is equal to 0. And x equals equation is a vertical line through that x value. So we're going to have a straight up and down vertical line through the x value of 0. And as we draw this out, it's going to be a solid line because our inequality does have that equals to line underneath it. So a vertical line through the x value of 0 is going to correspond with that y-axis. And then as we're looking at x values that are greater than or equal to 0, we're going to be looking at everything to the right of that red line. Now I'm going to move on to this bottom one, y is greater than or equal to 0. If we replace that inequality with an equals to, we get y equals 0. A y equals equation is a flat horizontal line through that y value, and we're going to graph this one out with a solid line as well, because we have our equals to underneath that inequality. So we're going to have a flat horizontal line through the y value of 0, and then we want y values that are greater than 0, so we're going to be above our blue line. So we're starting to see some overlap in here, and what I'm noticing is that these two regions that we have graphed out right now are overlapping in the first quadrant. So our solution set is going to end up somewhere in the first quadrant. Now we've still got two inequalities left that we're going to need to graph out and shade. So this might get a little messy in here having 4 different colors shaded out. So I'm actually going to switch my graph up just a little bit. We just said that these two were overlapping in just the first quadrant, so we know that's where our solution set is going to end up. So I'm going to look at a graph of just the first quadrant, and I'm going to focus on these last two inequalities to see if we can find the overlap there. So this first one, I need to get that y alone. So I'm going to subtract that 2x over to the right-hand side. So we're going to end up getting y is less than or equal to negative 2x plus 10. I'm going to pretend that's an equal sign in there for a second, and then we're going to have a y equals mx plus b equation with a b value of 10, so our y-intercept is 10. Our slope is negative 2, so I need to go down 2 over 1, and I'm going to do that a few times to give myself a nice picture of what this graph is going to look like. This is going to be a solid line since our inequality does have the equals to line underneath it. Now I want to pick a test point, so I'm going to pick 0, 0. If I plug that in, we're going to get 0 is less than or equal to negative 2 times 0 plus 10. So negative 2 times 0 is 0, plus 10 is 10. So we get 0 is less than or equal to 10. That's true, so we want to shade on the same side. But remember, we're being bounded by this y-axis and this x-axis from what we were seeing before. So I'm really only going to shade this triangular region below this green line, but above the x-axis and to the right of the y-axis. So we've got that portion from this inequality, and then we've got one more inequality that we need to look at, but again, we need to get y alone. So I'm going to subtract the 2x over to the right-hand side. So we get 3y is less than or equal to negative 2x plus 14. I'm going to divide the 3 over, so we get y is less than or equal to negative 2/3 x plus 14/3. Now, if I pretend there's an equal sign in there, we get the y equals mx plus b equation, y equals negative 2/3 x plus 14/3. Now, 14/3 is 4 2/3, so a little bit short of 5. So I'm going to plot out my y-intercept right there. And then my slope is negative 2/3, so I need to go down 2 spaces from that point and to the right 3 spaces for my next point. And I'm going to do that a couple of times to get a good idea of what my graph is going to look like. Our inequality does have the equals to line underneath it, so we're going to graph this out using a solid line. Our graph does not go through the origin, so it's going to be safe for us to test 0, 0 again. So we're going to get 0 is less than or equal to negative 2/3 times 0 plus 14/3. Now, negative 2/3 times 0 is 0, plus 14/3. We get 0 is less than or equal to 14/3. That's a true statement, so we're going to shade on the same side as 0, 0. But again, just like we saw with our green graph, we're bounded by our axes because of these first two inequalities that we looked at. So I'm going to shade below my orange solid line, but above my x-axis and to the right of my y-axis. And then again, we're looking for where these regions overlap. So we've got this small little space right in the corner of this first quadrant that I'm going to shade in bright pink. This region that I'm shading right now is the overlap between all 4 inequalities that we just drew out. So that's our solution set. That's going to be it for this video. Thanks for watching.